Performance measurement. I mentioned that the key advantages of numpy are convenience and speed of computation. You will often work with extremely large datasets, and thus it is important point for you to understand how much computation time and memory you can save using numpy compared to standard Python list. Create a Python list of 10,000 elements from 0 to 9,999. Range of 10,000. Create a list. Calculate the computation time of the operation given below, which calculate the cube of each element in the list. Time function calculate the time of this operation. This expression calculate the cube of every element in list C. To see the output, run the cell. It will take a time 2.45 millisecond per loop. This is in standard Python. This is a standard Python code. Now we will do this in numpy array. Create a numpy array of 10,000 elements from 0 to 9,999. C underscore numpy is equal to np dot range of 10,000s. It create a list of 10,000 elements. Calculate computation of time of the operation given below, which calculate the cube of each element. Run the cell. This operation will take time 24.4 microsecond per loop. It means the numpy array is very fast than standard Python lists. Still not convinced? Want to see one more interesting example? Again, create a list of 10,000 elements. L1 is a list and has 10,000 elements. Create a Python list of 10,000 elements. Start from 0 to this, and then calculate the square of each element of the list through list comprehensions. L2 has a list which has 10,000 elements. This expression means the square of each element in the list L2. Run the cell. Calculate the computational time of given expression. List of map of lambda function parameter x comma parameter y colon x multiplied by y. L1 is the first list and L2 is the second list. In map function we are used iterables, for example list L1 and list L2, and this means x element of L1 and y element of L2 multiplied by each other, and return the list. Also return the time taken by this operation. See the result. It will take time 1.08 millisecond per loop. Now this operation we will perform in numpy array. Cast the Python list L1 and L2 into numpy array. A1 numpy dot array of L1, B1 is equal to np dot array of L2. Run the cell. A1 is a numpy array now, and B1 is also a numpy array. Calculate the computational time of given expression same as the above. A1 multiplied B1 means every element of A1 multiplied by the every element of B1, and time it return the time of this operation. It will take a time per microsecond per loop. See the contents of A1. These are the elements from 0 to 9,999. See the contents of A1 multiplied by A1. It means each element multiplied by itself. It means 0 multiplied by 0, 0, 1 multiplied by 1, 1, 2 multiplied by 2 multiplied by 2 is equal to 4, and so on. So I can do everything without even writing a loop.